Okay, our next topic in Unit 5 is, now that we've talked about slope, we're going to talk about applying slope, like applying it to real life situations or applying it to events or scenarios that we might encounter in our lives. The first thing I want to talk about in regards to applying slope is feet. Not that kind of feet, though. I was really thinking more like this kind of feet, although I guess they kind of... Okay, this kind of feet. As we know, most rulers are 1 foot long. And as we also know, on those rulers there are 12 inches. And that happens because there's 12 inches in every foot. And that is a ratio. So we've been talking about ratios, and the ratio of inches to feet is for every 12 inches you have 1 foot. Now, I could make a table like we've been doing, and I could say if 1 foot has 12 inches, 2 feet has 24 inches, and 3 feet has 36 inches, and 4 feet have 48 inches, and we could keep on going and going and going, but you know what we liked to do with these kind of tables? We liked to make them X's and Y's, and then put them on a graph. So, can I graph 1, 2? Yeah, so I took my 1 and 2 pair and I made a dot on a graph, 1, 2. Could I do the next one? 2, 24. Could I do the next one? Sure, 3, 36. Could I do 4, 48? Yeah, it's just not going to fit on my graph. But I think what you're seeing here is, hey, look at that. It makes a straight line. The next question I have, though, is, now that we've seen that this is a linear situation, what would the slope of this line be? And before we answer that question, notice at this point we combined the idea of a ratio with the idea of a table, with the idea of plotting points on a graph and having them come out linear, and now we're going to combine this with the idea of slope, so we're going to pool together all of the concepts that we've talked about in Unit 5 so far to answer this one question. What would the slope of this line be when we talk about inches per foot? Well, if you look at any two dots on this screen, you can see that it goes up 12 and over 1. The slope is 12 over 1, which is also the same as the rate that we started off with at the beginning of the problem. And so what I want you to see here is that slope is the same as rate. I'm going to say that again. Slope is the same as rate. Slope is the same as rate. And if I'm repeating something 3 times, you could probably make a good guess that that's something you probably want to write down. Slope is the same as rate. This is what we call a linear relationship. When you have a ratio that produces linear points and you get a consistent slope, we're talking linear relationships now. And since we're talking linear relationships, let's look at this table and notice every y is 12 times as big as the corresponding x. So each y is 12 times whatever the x is. Like when y is 48, that's 12 times 4. And when y is 36, that's 12 times 3. And notice when we put this into an equation, 12 is the slope, and 12 is the ratio, and 12 is also the number that goes in front of the x in the equation. Okay, so we're kind of connecting every concept together here, and this is what we're talking about when we're talking about applying slope. And that's really all I want you to see today. And I just want you to get a little bit more practice at this by doing one practice problem. And then we're going to be done. So, your practice problem is, we all know that $1 is 4 quarters, and 4 quarters is $1. So that's a ratio of 4 quarters for every $1. Okay? You can turn that into a table where X is the number of dollars and Y is the number of quarters, and you could figure out for $2 how many quarters that would be, and $3 how many quarters that would be, and $4 how many quarters that would be, and then you can graph those points on a graph, and then I want you to answer this question. What do you notice about the slope of that line that you end up with compared to the ratio of quarters to dollars that we had at the very beginning? So take a few minutes, maybe pause this screen, fill out the table, make a graph, and then I want you to just answer this question in red. What about the slope and the ratio? Are they the same? Are they different? Are they similar? Once you've done that, we are all done. Thanks a lot. I'll see you tomorrow.